kind of want to track where a water droplet goes. A single water droplet, we want to track it through the water cycle. So how long the water cycle process takes. Following a single droplet, if we assume that we start at evaporation, that average droplet will spend 98 years floating in the ocean. Just hanging out. So out of 100 years, 98 years of that time would be swimming around in the ocean. It'll spend a little under 2 years as frozen ice. Not melted ice, which would be liquid water. And then 2 weeks in lakes and rivers, and less than 1 week in the atmosphere. So we think about how long does that moisture stay in the atmosphere? About a week. That's it. So as water evaporates, it takes about a week for it to go through its little process, and it starts to precipitate. We spend about 2 weeks in lakes and rivers, and then eventually flows down to the ocean, and that's when we set. Yes?
So you're saying that every part of water pretty much is just in your regular cycle?
Yeah. It's somewhere in the cycle.
So it's just every other 98 years.
Well, it's not, perfect. It's not exact. But yeah, it's about that much.
How did they track that?
Yeah, how do they track that?
That's a great question. I don't know.
So most of the water right now in our Earth is in like it's in that stage.
Most of the water on Earth, 98% of it, is in the ocean storage.
That's why it's very low.
Exactly. And when we think about groundwater, that's where most of you guys probably in this region actually get your waters from groundwater. You guys have pumps at home. Okay. So if you guys have your own pumps at home, you probably get your water from the ground. I know mine's extremely rusty, and it's the first time I've had to buy salt for my filter since I was probably living at home. So I keep forgetting to buy salt, and next thing I know, I'm taking a shower in the morning, like, man, why does it taste like I got a bunch of coins in it? I'm like, oh crap, forgot to buy salt. So yeah. So you might notice that with groundwater you get a lot of other minerals. So it's kind of neat, but the ground is actually one of those great purifiers. If you have the correct soil types, it will actually filter out a lot of pollutants.
Like our sump pump or whatever, that stuff out water through the water drain. Like sometimes it'll just sit in the drain and goes out to the field.
That's your iron content. So, but basically, the one thing I do want you guys to think about is, we think about how slow does it take water to move. Well, if you have groundwater, it takes about a human's lifetime to go 1 mile. So groundwater moves extremely slowly. At the same time, it takes extremely long amounts of time to recharge your groundwater. So when we have these things called aquifers, it does take forever for that stuff to recharge. It takes a very long time. So when we talk about the Agawala aquifer out in the Midwest, on the Great Plains, that is a shrinking aquifer. I'm meaning that it is getting tapped out more than what's getting put in. Okay? So if you're taking out more than what you're putting in, it's shrinking. Or we're losing that water. But that's because it takes well over 100 years for that water to recharge itself. And if there's a drought, that just makes it worse. So while you guys do understand that I'm not a big fan of global warming, conservation is a very intelligent way to reach sustainability. If you are tapping out of the aquifer, try not to waste water. Now, I know some people who go a little bit insane about it. I'm just not really that big into it, but if you get your hose out in the yard, turn off the water. You don't need to have the hose running all day. That's a complete waste of the water. So you do want to work on conservation. It's definitely worth doing. When we think about our surface water, so we understand that 98% of the water on Earth is in the oceans, which means it's completely salty. You can't really drink that. Oddly enough, if you're thirsty enough, think you need some water, you start drinking the ocean water, you actually get more dehydrated thanks to the salt. Yep.
Yeah, that.
So how do you get salt water?
You have to let the water evaporate and then recollect it. Or you desalinize it, which is an extremely expensive process.
Like how would you, like if you were on an island and you wanted to get water, is there like a way to do it? Do you have to have like a
No, I'll show you how to do it. Mostly, if you're going to do that, I've created a barrel and collect the rainwater. And then, so we think about the fact that 98% of the Earth's water is in the oceans. That leaves us with just 2% of what's left over. And of that 2%, most of it is frozen or salty. Because even your groundwater can be salty. Which is why we need filters. And then 2% of the water is frozen. Now, guys, when we talk about surface water, surface water is basically a blanket term for any water that's actually on the surface. It's ocean water on the surface. Yeah. Okay, so notice that one thing you guys probably should notice out of all this, you notice that the percentage don't quite match up. Alright, that's because water is in this constant state of flux. It's always changing from one phase to the next. So it's really difficult for hydrologists, which are people who study water, hydrologists, it's really difficult for them to get exact numbers. So with hydrology, it's not really an exact science. We know a lot, but with some of the numbers, we can get you more qualitative rather than quantitative. We can't really get you exact hard numbers. In physics, you can get things accurate down to the nearest thousand. But when we think about hydrology, we're kind of within 5 or 6%, maybe plus or minus 10%, one way or another. And so it's kind of really hard to get those numbers really accurate. The one thing I do want you guys to pay attention to right here a trillion ton of water. Every day, the sun evaporates over a trillion ton of water. Well, you think about take a day like today. Take a day like today. That is a lot of water. When do we actually have our highest evaporation rate? Try again. It's actually the winter.
because it snows and then it melts and then it'll snow again and then it'll melt.
Nope.
The sun reflects off on all the.
Nope.
What's the correct?
Because the sun is that.
You're closer by about a few thousand miles. Which is really that big of a deal.
What you said?
Because it doesn't matter which place you are, whether you're in the hemisphere during the winter or you're in the southern hemisphere during the winter, your highest evaporation rates are during the winter.
Because.
Your relative humidity is extremely low. So therefore, the sun actually can evaporate the water. There's room for the water to evaporate. During our summer months, it's very humid.
So,
Water has nowhere to go, so it just sits.
so the less humidity, the more evaporates.
And we'll confuse you guys later when we talk about weather with that term. So, let's talk about all this stuff in graphs. This is kind of an odd looking graph. This is, again, these are not really hard numbers you guys need to write down, but just so I want you to put it in perspective about how much water really is not out there. If this column right here on the far left represents all the water on Earth, this tiny sliver at the top is fresh water. And then, if we take that little sliver and we zoom in a little bit more, we can slice it up into this proportionment. So out of that 3%, 70% of the 3% is locked into ice caps and glaciers. So the majority of our fresh water is actually locked into the polar ice caps.
So can that fresh water transfer to salt water?
Yes.
So then you're saying someday we won't have fresh water?
No, because it's a constant cycle. Because even though that may run off and go into the oceans and become salt water, when water evaporates, the salt can't go with it. So it becomes fresh water again.
Oh, so it'll only stay 3% fresh water.
Yeah. Not always, but yes.
So how do we get the water from the ocean? Just like breaking off chunks of it?
Actually, what a lot of at the front edge of the glacier is the melting retreat. So you get these melt waters, and what a lot of communities do, especially in the Rocky Mountains, they will actually put a pumping station right there at the foot of the glacier and pump the fresh water away from
Just
the
wait
glacier.
for it to melt.
So how do fish live in salt water?
I don't know. I'm not a biologist. I can tell you anything you want to know about rocks, but that's the fleshy stuff. No, that's not me.
Isn't like the rain fresh?
Rain is fresh water.
It's like rain.
That's why you collect it.
That's what you said.
I understand.
Now, like I said, so 70% of the 3%, which really breaks that down to 2.1% of all the water on Earth, is in our frozen glaciers and ice caps. 30% of the 3% are basically about 0.09%. This is a little scary to think about it. That's not point, that should be 0.9%. It's groundwater. So when we think about our groundwater, that's where most of us get our water from. That represents less than 1% of all the water on Earth. And then we get even smaller. The surface water, lakes, rivers, and streams, 0.3% of the 3%, which is our 0.09% of the total water. And then, if you look at that even closer, you can see we take this 0.3% of the 3%, and we're going to break that down even more. Out of all that, 87% of that is locked into freshwater lakes, the Western Great Lakes, which are huge bodies of water. And think about some of the greater lakes. I think Caspian Sea is actually a freshwater lake. You know, the Aral Sea in Asia.
What would they call it the sea?
You have the chain of lakes that make up the East African Rift, which is where, how many of you guys have cichlids?
I have African sea.
Okay, so cichlids are actually formed in all these lakes along the East African Rift, and each time you go into a new lake, like Lake Tanganyika, you actually get a whole different species of cichlids. Yeah, they really are. That's why they're not community fish. You can only put cichlids with other cichlids.
Yeah, this one that we have pretty much stressed out the Oscar. The first Oscar we had that died, so we got a new one. And it really changed its colors.